Yeah, hello, good evening. Am I audible?
Yes, sir.
Can
Good
you
evening.
hear me? Hello.
Yes, sir. You are
Yes,
audible,
sir.
sir. Good
Yes,
evening.
sir, you're audible.
Audible.
Okay, okay, great. Yeah, so today basically we are supposed to start with week 4, but as week 3 assignment deadline is not over yet, so let me ask one that, is there any doubt till we discussed yesterday? Any doubt regarding linear dependence, independence, and span?
Yes, sir, I have a doubt.
Uh, uh, what is your doubt?
Sir, we have normally seen the determinant method to find whether the equations are linearly dependent or independent. But what if it is not a square matrix?
Were you present in my last live session?
No,
Uh,
I actually
can
missed that.
okay, no issue. Anyone here who can answer this question? Anyone want to discuss this? Just you don't have to give the answer, but at least discuss this question.
Can she repeat her question?
So basically, the question is to check whether vectors are linearly dependent and independent. One way is checking the determinant, right? We can write the vectors as columns
Yeah,
and check its determinant whether it is zero or non-zero.
yeah.
But if it does not form a square matrix, then
Hmm.
what we should do? In some cases, it may not form a square matrix, right?
Yeah, yeah.
Yeah. So in that case, what we should do?
Try to solve it through the reduced row echelon form, Gaussian
Huh.
elimination.
Any other?
Yes, sir, I knew that it was to reduce
That
row
if
echelon
we
form,
can
but
write it in linear equation form,
Hmm. Hmm.
and
Yeah.
then we will check that if the coefficient is at least one coefficient is non-zero, then we can identify, I guess.
yes, sir,
Yeah.
I got that by writing linear equation, but it is very
Mhm.
cumbersome process.
Yeah,
Or
Is
very
there
or
any
we
cumbersome.
solved
can
way?
check, sir, any multiple of the others. That's how
Right.
we can check
Right.
it always.
Exactly. Exactly. So
Yeah,
let
but every
me.
time we will not get a straightforward thing, no? So that's why I said that. That the
So
linear
yeah.
combination thing.
Okay. So basically, in this course, for
And
at
as
least
far
for
as the
this course,
conversion process is concerned, so in linear algebra, we will get that type of process. So at least we
yeah.
should be ready for.
So
Conversion process is so
basically,
lengthy.
yeah. So
Yeah,
basically,
yeah,
for R2 and R3, right? We discuss only for these two cases, and the rest of the cases are similar anyway. So for R2, how many cases are possible?
Three cases possible.
Huh. So if so, let me write it again. Yesterday I have written it. So if there are more than two vectors, if in a set there are more than two vectors, then
Then
what?
it is dependent.
Huh, more than two vectors, then the set is linearly dependent, right?
Yes.
Yeah. So remaining cases are either one vector or two vector, right? So if the set has only one
Independent.
element and that is non-zero, then what it should be?
The span.
Inde- Independence.
Yeah, correct. Then linear independent.
Hmm.
And if it has two vectors, then we can calculate the determinant, right? It will become 2
Yeah.
cross 2.
Yeah.
If the set has two vectors, then calculate the determinant.
Determinant.
So for R2 is sorted.
Or any of two vector is 0, then it will be dependent.
If 0 vector is present, anyway it will be linearly dependent. Correct. So R3, again, more than 3, linearly dependent. And if it is 1, only 1 and non-zero.
Independent.
So same, linearly independent. 3, exactly 3. Check determinant. And if 2, there are only 2, then for linear dependency, one must be multiple of other, must be scalar multiple of other.
If this does not hold, then it is not linearly dependent.
If it is not linearly dependent, then it is linearly independent. So if one vector is not multiple of the other, scalar multiple of the other, then it must be linearly independent.
It would be linearly independent.
Okay. Is it
But
clear?
it could be combination of a scalar multiple and a vector addition also, no, sir?
No. So when in between two vectors we are checking, it is enough to check only scalar multiple, because
correct.
yesterday I said, you remember?
Yeah. For two
In
vectors,
this
yeah,
span
it's
will be
obvious.
only
Yeah,
one thing.
Yes,
One
sir,
step.
it's obvious. Yeah.
Yeah.
Thanks.
Yeah.
Sir,
So who asked me this question?
Yes, sir, I got it.
So you got it, no? So for R2, R3, this is sorted, and once you come to R4, there is no way out without this checking linear equations. And
Okay.
for that, you have, I mean, you know what Gaussian elimination is, and
Yes,
you
yes.
know the algorithm, so write program and solve it.
Yes, yes.
Okay.
Yes.
In
So,
R3, you can solve it by hand.
sir, so if there are 3 vectors in R4, we can't apply the same rules as R3.
No, then there is an issue, no? So, I mean,
Then we have
scalar
to go the
multiple will
long
not
way.
only solve the issue.
So we'll have to go the long way only.
Right. Because then the third vector can be in the span of the previous two. So it will be difficult. So in that case, you have to find out what is the span of the previous two. Then you have to check whether on that plane the third vector is situated or not. So it's better to solve by linear equation. I mean, it will take same time basically. Okay.
But in some questions, we are given matrix instead of vector.
So today I was about to
So,
come in that. I will come to that.
yes, sir. I don't know how to what represents what in if matrix is given. For example, sir, it is a question in activity question 4.1.
So today I have
question number 2.
Yeah, today I want to discuss one question like this
Yes,
also. So
yes.
Sir, just one small question again. If a system of equations or the vectors do not have a solution, we will say they're linearly independent, right?
So you have given some vectors and you have created a system of linear equations, then it has no solution, is it?
Right. So we can't find out the coefficients.
No solution, but no solution cannot happen for homogeneous equation, no? So when you are checking linear dependence or independence, you have to equate it to 0.
Right.
So the system you get is homogeneous equation. So no solution cannot happen there, right? Because 0 is always a solution for x equal to 0.
Okay.
The
So
system
that
of equation
possibility
you will get
will,
like this, right?
Yes, sir.
And 0 is always a solution. So there are only two possibilities, either unique solution or infinitely many solution.
Yeah, because the coefficients can all be 0, and that will
Exactly.
always, the trivial
So if it
solution is
is,
always
exactly.
the trivial solution is always a solution.
So if it is unique solution, then it is linearly independent. And if there are infinitely many solutions, that is linearly dependent. Correct?
Yes, if there is a unique non-zero solution, then it is linearly
Unique
dependent.
non-zero cannot happen.
In unique, linearly dependent cannot happen.
No, see, for this type of equation, if it has a unique solution, what is the solution? Zero, right? Because you know zero is always a solution, right? And
Yes.
what does mean it has a unique solution?
Okay.
So zero
Okay, I
is
got
that
it.
solution,
Okay.
right?
It will always
Once
be
it has,
zero or
yeah, exactly,
infinitely many.
exactly,
So
exactly,
it will be, if it's infinitely many, then it is linearly dependent. And if it
exactly,
is zero, unique solution with zero, then we would say it's linearly independent.
exactly.
Thank
Correct?
you. Yes,
Understood?
yes, sir.
Yeah,
Thank you.
great. Okay.
Sir, the
Sir,
first,
can I ask you a question? I raised my hand actually.
Yeah, go ahead.
Sir, it is based on week 4 videos. So 4.2 in 4.2 video, sir has taught us how to find out basis, right? So
But I
in
have
that,
not discussed that yet. So can I discuss and then you can ask?
yeah, sure, sir.
Okay,
No
let me
problem.
hear your question first. So what is your question?
Yeah, actually, in that video, he has taught two methodology to find out. One is deleting, another one is adding, right? So it is
Okay.
appending. Yes, appending basically.
Yeah.
So in the method 2, when he taught method 2, deleting one, he taught us a 3 by 3 sorry, R3 span, right? R3 span. So I did not understand the example. That example, whatever sir has taught, I did not understand that example. Can you teach that example once again?
So I will discuss that. Okay.
Okay, thank you, sir.
sir, the first page, what you wrote, can you please scroll it up, scroll it down, please?
This one?
Yes, sir, yes, sir. So
Yeah.
please come down again. नहीं, ऊपर जाइए.
This is what I have written till now.
Sir, इसमें जो second point है, only one element like non-zero, then it is linearly independent. Like if I do have only one element, then it is linearly independent. That's what you're trying to say.
Exactly. So if it has only one vector, the set has only one vector v, and this v is non-zero, then it is always linearly independent in any vector space, right?
And more than two vectors means that is also linearly dependent, either in case of R3 or in case of R2, both cases.
No, in case of R2, if there are more than two vectors, then only it is linearly dependent. In case of R3, it has to be more than three.
Minimum it has to be 3.
Right. So in week 4, when you come to basis, that is basically the reasoning for that. Okay.
Okay.
I will explain that today.
Okay.
Yeah. So I assume that till week 3, at least the concept, at least the definition and how we calculate it, everything that is clear more or
Sir,
less,
one
right?
general question can I ask?
Yeah.
Yeah, so sir, I was little confused between row rank and column rank. So both will be same or it can be differ
No,
as
both
per
will
the
be
question?
same. Row
Both
rank
will
and
be
column rank
same,
are same. Yeah.
always.
Always.
So we can write as per our convenience, right?
Yeah, right.
Yeah, correct. Thanks.
Okay.
Sir, I have one quick question, if you don't mind.
Yeah.
So it's more of a clarification. So while studying, what I saw was basically a linear independent set. They mentioned in two different points that it has to be a maximum independent set and a minimum spanning set. But it's always one and the same, right, sir? If something is maximum independent set, then it is definitely minimum spanning set, right, sir? For the
Exactly.
same max.
Yeah.
Yeah. Because what I saw was in a couple of questions, they're putting it in a separate point. So I couldn't come up with a scenario where
Those are
maximum
basically if
independent
and
set is.
only if statement. Both of those are
Yeah.
them are true.
Yeah. Thank you. Thank you for that.
Yeah. Yeah. So just at the beginning, I am just giving this thing for knowing basically who are you attending this session. So I am putting this in chat and then we can start with the session. Okay. Okay. So everyone got this thing, right? This link.
Yes, sir.
Right?
Got it. Got it.
Okay. So I am moving ahead and you fill this
Yeah,
one.
yeah. We are
Okay.
filling it. Correct.
Okay. Great. So at the time you are filling it, I will come back to this slide for the questions. So till this point we have seen the vector space, which is R, R2, R3, so on, and the subset of that, basically subspaces of that. But there is another type of vector spaces which we have already seen, but we have not seen this as a vector space, that is set of matrices. Set of matrices, n cross n matrices. So not necessarily n cross n, it can be m cross n also. Okay, so number of rows and number of column may be different. Now I have said that when I am giving an example of a vector space, I have to give a set and what are the operations. So operation is basically addition is matrix addition. You know what matrix addition is, right? And
Yes,
another
sir.
is
Yes.
Yeah, another is scalar multiplication.
Scalar multiplication.
So what does this set mean? I mean, what this set basically look like? So suppose this is my set A such that A is M2 cross 3 R. So this is the notation. So these are, that means the elements which we are taking, that are those are real numbers. Okay. So the any general element of this set. Okay. So each element of this set will look like, so it is a 2 cross 3 matrix. That means 2 row and 3 column. Right. So A1, A2, A3, say B1, B2, B3, like this. So any element of this set will look like this. So if I say 1, 2, 5, minus 7, 0, 9, this is an element of this set, this vector space. Okay. And you know how to add it. So at each element, you will add the element. So basically element wise or
Oh, sir,
coordinate
can I
wise
just
maybe.
ask one doubt?
Yeah.
Sir, actually, could you just explain what is rank of a matrix here?
Rank I will come later.
Okay, okay.
Yeah.
A2 prime, A3 prime, B1 prime, B2 prime, B3 prime. So can you tell me what is the addition of these two?
Yes, sir. A1, A1
A1 plus A1 dash.
A1 plus A1 plus
A2
A2 plus A2 prime, A3 plus A3 prime,
Okay.
B2 plus B2 prime, B3 plus B3 prime.
Okay. So is this addition closed under this operation? Is this vector space closed under this addition? So closed means
Yes,
I
sir.
am taking two elements. This is my A, this is my B. I am adding these two. The result which I am getting, is this inside V?
Yes, sir.
Yes, sir.
Yes. So when I am adding 2 cross 3 matrices, I am getting again a 2 cross 3 matrix.
Yes.
Right?
Yes,
No
sir.
issues there. Okay. Is this addition commutative?
Yes, sir.
Yes, sir.
Yes, right? It is
Yeah.
easy to check.
Yeah.
Associativity also easy to check. Now tell me, what is the zero in this vector space? What is the zero element in this vector space?
Sir, 0, 0, 0, 0, 0.
Exactly.
Negative
So
of
a zero
elements.
matrix 2 cross 3. All the elements are zero, right?
Yes. Yes.
So this is the zero element in this vector space. Okay. Inverse, you know, basically you will get a minus at each place, each element. That will be your inverse. Scalar multiplication, I am not explaining. I hope you know what is scalar multiplication. You have to, if you take C into this C will come at each position, right?
Yes, sir.
Okay, great. So
Sir, this
now,
so this M denotes that we are talking about matrix.
This M is basically for the matrix. This is rows and column, and this is from where we are taking the elements.
Okay,
so
thank you.
Okay. Yeah. So this is a vector space. This part is clear, right? So when we are talking
How
about
we
vector
got
space,
this 0, 0? Like how we can say that all the elements, those elements will be 0, 0?
So what you have to find for 0, you have to take any matrix, you have to add some other matrix which must be 2 cross 3 matrix, and you will have to get back the matrix back, right?
Yes.
So with this A, suppose this is my A.
Okay, existence of inverse.
No, not inverse. First, existence of 0.
Okay.
So what matrix should I add with A so that after adding I should get back A again?
Yeah.
Zero matrix.
Zero
That is
matrix.
0 matrix, right?
Yes, sir. Thank you. I got it.
Of the same order, basically. That is
Existence of
the
identity. This is right, sir?
this is additive identity, but you better not to use the word identity because then you will confuse with the identity matrix.
Yeah.
That is different thing. Okay.
Yes.
So better to use 0 matrix.
Okay.
Okay. So 0 matrix of order n cross n. So here it is 2
This
cross
is,
3.
this is the zero vector also, na?
This is the 0 vector, exactly. This is the 0 vector in this vector space. So remember, in this vector space, every element is a matrix. Okay.
Sorry, a short question here. If a zero vector is present, then we can say that inverse is also there.
You have checked, no? Inverse is also there.
Sir, is it true in every case?
No, it may not be.
Okay.
It may not be. I mean, the inverse may not exist in that space. So on the first day, I have given the example, right?
So
In case of
saying
natural
that-
number and addition, if you take 0 exists, suppose I am taking 0 inside my set of natural numbers. Okay. So 0 exists. Does inverse exist in that case? No, right?
Sir, can you explain by writing it? I'm not getting.
I mean, just take any natural number. Okay. Set of natural number I am taking. 0 is there.
Okay, sir.
So 5 plus 0 will be 5, right? So 0 exists.
Right, sir.
For any natural number, you are getting back the natural number. But
But
inverse
minus
of
5
5,
is not a
what
natural
is
number.
inverse
It does
of
not
5?
exist.
Minus 5. So minus
Minus
5 does not
5.
belong to it. Okay.
Okay. Now I got it.
Yeah. Okay. So
Sir,
this vector
actually-
space, yeah.
Sir, I'm joined little late. Can you quickly recap previous slide so that I can track?
So basically, earlier I was explaining the previous thing which I did yesterday. So you can
Yes.
check it later. Now, the basic thing which I have started today, that is, I am giving another example, another type of example or class of example for vector spaces, which is set of n cross n matrices.
Okay.
So in this set, all the elements are matrix. Every element, each element is a matrix. Okay. Suppose I am talking about M2 cross 3R, right? That means all the set of all the matrices of order 2 cross 3. Okay. And these
Yes.
R denotes basically we are dealing with real number. So all the elements are real number. Okay, so these type of elements are general form of element in this vector space. What is addition? Addition is like coordinate wise again, matrix addition basically. The 0 vector is 2 cross 3 0 matrix because we are dealing with 2 cross 3. So if it is m cross n, 0 vector will be m cross n 0 matrix. And scalar multiplication, you know the matrix scalar multiplication. If you put a C here, it will come inside with every element. Right?
Yes.
That is the scalar multiplication. So till now I have discussed only this much. Okay.
Okay.
Okay. So these type of vector spaces we have to deal with. Now similarly, what other concept we have discussed that is also applicable here. So suppose I am giving you 2 cross 2 matrix. This is a vector space, correct? Can you tell me what is the 0 element here?
0 0
0 0 0.
Correct. So the 2 cross 2 0 matrix. Okay. Now, if I am giving you this vectors, the 4 vector I am giving you. So these are 4 vectors in this space, right? All these are 4 cross 4 matrix. Correct? Can you tell me what is the span of this set?
Complete matrix. Each
Complete
element
set,
of 2
right?
cross 2
2
matrix.
cross 2
Yeah.
R, right. How
We
can
add
you
all
do
of-
that?
We
So
add all-
basically, first one, if you see, we know how we check the linear combination. Let's take A, B, C, D as 4 constant, A into first one and B into second one,
Exactly.
C into third one. So we can get any
Very
number
good.
we want.
So general form of 2 cross 2 matrix is basically A, B, C, D. Correct? So
Yes, sir.
I have to write linear combination of these 4. So there should be some constant term or real number. There should be some real number. Like that. So what are there? There should be, so this should be A, this should be B, this should be C, and this should be D. So clearly any matrix which is in M2 cross 2R can be written as a linear combination of these 4 matrices. Correct?
Yes.
No issues till this point?
Yes, sir. Correct, sir. Clear it.
Correct.
यहाँ तक clear है, sir. Clear to this point.
So I am calling it V1, V2,
Sir,
V3,
sir.
V4.
Hello, sir. Can you explain the span of a vector with any other than matrix example? Can you please explain? Only the normal value.
Yesterday I have explained, no? So
Actually, I missed that part.
okay. So span of some vector basically set of linear combinations. All set of linear combination. Okay. So yeah, so I will give you an example of that also. First, let me finish this, okay? Otherwise, I have to come back here again. Okay, so now my question is this set, this V1, V2, V4, V3, V4, is this set linearly independent?
Not,
So
sir. It is a it is
Linearly dependent, sir.
It's linear.
No, sir. It is a
independent.
linearly independent.
No, sir. Totally independent.
It is a
That is exactly four.
Independent.
Okay.
Independent.
Sir, it is exactly 4. That's why we have to check it with determinant.
No, here checking with determinant will be very difficult because here each element is a matrix. You cannot write again this as a matrix. Right?
Sir, we can say that because every column for independence, every column must have a pivot element.
No, I mean these are all elements, right?
Yes, sir.
I am not putting this inside a matrix. So earlier what I was doing when I was dealing with R2 and R3, I am writing each vector as a column of a matrix. That is separate thing. Here each element is a matrix. Right? Can you see the difference? So if I am talking about R3 and I am giving you an example like 1, 2, 3 and 0, 1, 5 like this. So at that case, you are putting this as a column of a matrix like this, right? But here each element, this is the first element, this is your V1. This is itself a matrix. Okay, so here you have to go by the definition only, no other way.
Can we find the determinant of each matrix and then add it?
That will not solve anything, right? Because these are one element, right? There, what we are finding? There we are finding the determinant for finding the solution of the coefficient, right? But here it is not that case. Here each element is a matrix. So if you find the determinant, every determinant, I mean, for every matrix, the determinant is 0 here, what I have given. Right? But that does not prove anything because I am not interested in determinant of each element. Right? Earlier, when I was talking about 1, 2, 3, I was not interested in finding the determinant of one element. I mean, it does not make any sense, although. But I was not interested what is there. I was interested all the 3 vectors or 4 vectors together, what they represent. Right?
Sir, can we say that each matrix is this one? In this one, each matrix is set of vectors.
Each matrix is a vector. Each matrix is a vector in this space.
Okay. So we cannot consider it as writing the columns into vectors, right?
No, there is no way for doing that.
Sir, I think, sir, we can observe by just saying that every other coordinate have one in the set.
So basically here you have to go by the definition. What was the definition? So if I write this
AB1, AB2, A3,
A1,
like
B1,
2AVN,
B2,
that has to be equals to
A3,
0.
B3, and A4, V4. If this is 0,
Yes,
right?
sir.
Then what are the solution for A1, A2, A3, and A4, right?
Yes, sir. Yes, sir. Yes,
So
sir.
let me write. So this is my first element, right? This is my second element. This is my fourth element, third element.
Third element.
And this is the fourth element. And what is zero vector here?
0, 0, 0, 0.
4, 0, 0.
So this is my equation I am getting.
Yes, sir.
Right? So what about the first one? A1, 0, 0, 0.
0, A2.
2, 0, 0, 0. So 0, 0, A3, 0. 0, 0, 0, A4. Right?
Yes, sir.
Now if we add all these matrices on the left side, what you will get? A1
A1
plus
equal to
0 plus
0.
0 plus 0.
Yeah.
So A2.
A1, A2, A3, A4.
So, sir, it will be dependent, right?
Let's see.
Independent.
So what is the solution? If I equate this, so basically I am equating each element.
Each element is 0.
A2 is also 0, A3 also 0, and A4 is also 0. Correct?
And all is equal.
Sir,
All are equal and all are 0. So
All are
once once I am writing this combination, I am getting all the AIs as 0. What does that mean?
This is independent.
Yes,
independent.
Is linearly independent. Is it clear how I am checking this?
Yes.
So once
we
you are
can
in a
also see that
matrix,
we are
yeah.
one submission, sir. So we have calculated using all the operations, right? Moreover, by observation, we can see that we cannot obtain one element from another element by scalar multiplication. None of the 4 elements can be obtained from each other by scalar multiplication. That makes them independent.
But here it is easy to see, but there can be some cases where you have to go by this definition, right? In this case, it is easy. I agree that you can see, okay, this will not be span of the previous 3 or something like that. But it's better to understand the definition and go by the definition. Okay?
Sir, so here the vectors are in the form of matrix, right?
Yeah, each vector is a matrix. Here the case is very different.
Okay.
Okay.
So it can't be, we can't write it in the form of a vector, right?
This is a vector. I mean, every vector is a matrix.
Okay.
Vector space means what? Vector space means a collection of vectors, right? Now these vectors can be anything. One thing you have checked for R2, R3, those are basically the tuple, right?
Yeah.
Now here instead of tuple, I am getting a matrix.
Okay.
So in that case, for R2, R3, you are dealing with arrays. Now you are dealing with matrices.
Okay.
Sir.
Yeah.
Sir, if I want to calculate the span of a matrix, then I have to add all the matrix. This is the rule.
Yeah, you have to check what are the linear combination of those matrices. Okay.
Okay. Scalar
Suppose you have
multiplication and addition.
exactly correct.
Okay.
Okay.
It is
I
true
will
for
show some
all other
example also.
vectors. It is true for all other vectors also.
Yeah. Once you have to calculate span for any set of vectors, that is the way you have to.
If it is not a vector, only the value like 3, 4, 5, then same process, scalar multiplication and addition.
3, 4, 5 means what? Just number?
Yes.
I mean, like this 3, 4, 5 or just
Yes,
3, 4, 5?
yes.
Yeah,
Just,
like this.
Yes.
So these are vectors, no? These are also vectors. These are vectors in R3, right?
Okay.
These are vectors in R3, right? I mean,
I am
why
telling
there is a
about
confusion?
the span of a vector. If I am going to calculate span
Span
of a
vector means the scalar multiplication of this thing. Nothing else will happen.
Okay.
Now, if I am adding another vector with it, like this. Now I am saying you calculate the span. What you will do?
4, 4, 1 and 5.
No, not just adding this thing.
Oh.
This
3a.
this
3a plus
set.
b.
So it is
3a
basically 3a plus b
plus b, 4a plus minus 3b and 5a.
Sorry. Yeah. So this is basically your span, right?
Okay.
Clear?
From span, can I decide the independent or dependent?
Yeah.
From if I calculate the span of a vector, then also I conclude that it is a independent relation or dependent relation.
1 minute. So if you want to calculate the span, then no, I am not
What
getting
is
your
the
question.
actually what is the relation between linear independent and span of a vector? This is my question.
Okay. So when I am calculating, or we are calculating linear dependence or independence, then we are checking whether the combination, linear combination by which we are taking the vector, and I'm writing it equating to zero vector. Then what are the coefficient? Okay. And span is basically a vector space. Span itself is a vector space, which is basically set of all linear combination of the given vectors. Those two are quite separate things. There is a link, but as a set, or as a phenomena, those two are different. Is it clear?
No, not completely clear. Okay, you explain. I'm trying
So
to understand.
span of, suppose v1, v2, v3. Okay, this is a vector space.
Yes.
And the elements of this vector space is basically linear combination of this type. Okay. All
Yes.
such combination where AIs are in R. All such combination. This is a huge set. Okay.
Okay.
Okay. Now, if you want to say whether these three vectors are independent or not.
Yes.
Or not. Then what you are doing? You are writing this equation, making it 0, and checking
Yes.
if all the AIs are 0, then this set is, so let me call this set S. S is linearly independent. Otherwise,
dependent.
it is.
If all the coefficient means A1, A2, A3 in this example are 0, then it is linear
In this
independent.
equation, yeah.
Otherwise, it is linearly dependent.
Yeah. So these two are, as a phenomena, these two are quite different. This is a vector space and this is some equation. And basically, we are trying to find the relation between these three vectors. Right? And span of this thing means I am taking all this linear combination of those vectors. Okay? Yeah.
First I calculate span, then equal to 0, then I calculate the coefficient.
No. Here I am not calculating span. This is one equation. Just I am writing an equation. I am seeing what are the values for A1, A2, A3. And here I am varying my AIs over real number, whatever I get.
Okay. Okay, sir. Okay, sir. Now it is 90% clear.
Okay, you just take a look, think about it again. Okay. These two are basically quite different phenomena. That's what I am saying. Okay.
Sir, I want to make a request, sir. Sir, voice is a little low.
My voice?
Yes,
No,
sir.
sir. It's good. It's good.
No, I don't think so.
I think you should
check your
increase your
headphone
volume.
or something. Yeah.
No, sir. It is quite high.
Okay. So where were we? So these vector spaces, and for matrix we have done this thing, right? So suppose I am giving you this set of matrices. 1 0 0 1. This one. Can you tell me what is, first of all, tell me whether these two are linearly dependent or independent?
Independent.
Why?
Because that third element, A21, if I, let's say, I can't write one in terms of other.
0 0 is only coefficient, I think.
If you can write one in terms of other, then it must be linearly dependent.
No, we can't write. That's what I'm telling. I can't write it.
So why?
It's not dependent.
So rest everything is same, only one is different in between two of them. So whatever linear combination or I multiply anything for one to one, I can't write other in terms of that. Or like there is no way I can get 0, 0, 0, 0 from these two.
Right. Even if I just go by the definition, let's see what happened. Okay. Whatever you are saying is correct, but let's try going by the definition once because we are starting this type of element. So A 0 0 A, that is first one. B 0 B
V0,
B,
VV.
that is second one. Now, what if we are adding this to this, right? So what are the equation we are getting? A
A
plus
equal to
B is
minus B.
0. This place is already 0 equal to 0. This is B
0.
equal to 0. And last one is again A plus B equal to 0. So these
That
two
means A equal to
equations.
0.
What are the solution? A equal to 0 and B
Yes,
equal to 0. Correct? So these coefficients are 0 basically. So this set is linearly
independent.
Correct. Now what is span of this set? What is span of this set?
A plus B 0 B A plus B.
Exactly. Now you get it. A plus B 0 B A plus B. Where these A and B are coming from real number, right? You have to write it. This is the set. Okay. Okay. Great. So hopefully you have understood this type of vector spaces also, right?
Sir, when like in the future courses, when we study like data science with respect to these vectors, that time they will be telling us the link, or we have to link it ourselves.
You have to find the link. There will be data, right? Lots of data regarding different properties, maybe. Suppose you are dealing with data of student of a department, right?
Yeah.
So what type of data you can have in those? So first of all, their roll
Marks.
number, their
Name, roll
age,
number, date of
Marks.
birth.
marks of different subject.
Yeah, exactly.
So all those are basically your columns, right? All those are
Yeah.
lines, some are in. N can be large, very large,
Correct. Yeah.
right? So you can end up with in R 2000, suppose. So if I want to deal with this, I mean, the students of this maths 2 course in this term, that is more than 2000, right? So I have to deal with R 2000, right? So yeah, we can have to do that. So now it's on you how you can manipulate those, how you can do it faster. That's why this basic part is very required before you writing a code for something, or before you use some machine learning tools for that.
Sir, we will have to write codes for these vectors later.
I mean, everything you have to, I mean, either you
No,
have
no,
to do some
actually,
machine
since
learning.
we are very, at least for me, I'm very new to this field. That's why I'm asking, like, whether there will be codes related to vectors to be written or what, like that way.
Yeah, I mean, you anyway, you will have to deal with matrices in every place, right?
Yeah.
So, and machine learning is basically study of matrices, maybe I can say, vaguely.
Okay, okay.
Yeah.
Sir, a general question. Sir, which book should we refer for problem solving of linear algebra?
Have you solved all the problems in the portal? First, solve all the problem given in the portal. Okay. All the question,
Okay.
all the assignments, mock, everything. And then also you want to solve other problems, then I will say you look at this book, Incel, Friedberg. This is, and another writer was there, I forgot his name. So three writer, this book. Okay. There is a book for Incel, Friedberg, and someone, Spells. So there is a book of this, so you can solve the problems there. That is a good book. Or you have heard about Gilbert Strang. That may also you can follow because that will help you in machine learning eventually. Okay. Okay, great. So yeah, I mean, just 27 of you have filled this. I am copying this again so that rest of you also can try to fill it.
Sir, actually, I had not completed week 3 yet.
For roll number, what should we enter?
Your email ID has a roll number, not something 21, 5, something like that.
It includes F also.
That one.
Excuse me, sir.
Yes.
I am not able to join this Mentimeter.
So I am copying this code in chat box. Even there, from there also it is not opening.
Okay, sir, I got it. I got it just now. I'm okay.
Okay. So you just fill it. It will be easier for getting who are attending this session. And also it will be nice to have your feedback for week 3. Okay. So I am moving forward. Okay. If later I will come back. So this is the first question which I want to discuss. Okay. So this is a question for activity question. So if S is a okay, I should mute.
So this is week 3 or week 4 activity question?
Week 4. Okay. Probably week 4. So if S is a spanning set, so all of you have your pen and paper with you?
Yes, sir.
I will suggest it
Yes,
will be
sir.
better if all of you have pen and paper with you, okay? Because we will solve this problem. There are 7 problems I have selected. So we will solve this problem together. So if S is a spanning set of vector space V, okay, you know what is a spanning set, right? Spanning set means the set which, I mean, suppose you have a set S has some vectors V1 to Vk. That if you take span of that set, that will be your vector space itself, V, whole V. So that set is called spanning set. Okay. That means by spanning which you will generate all the elements of the vector space. That is your spanning set. So if you take any element from the vector space V, suppose you have taken V, small v, then you can write it as a linear combination of the element from S. Okay. That is the definition of spanning set, as we have already discussed it. Now, S union V, you are adding another element from the vector space inside the set. Okay, that is your another element you are including in that set. Now, it is saying that new set, S union V, that new set is also a spanning set of V. Okay, don't tell the answer now. Think what it is saying first, then we will come to the answer. I am just explaining what each statement is. So second one is span of an empty set is 0 vector space. So span of nothing, there is no vector. So what is that? Don't tell the answer now.
Oh.
Yeah. So if S is a spanning set of vector space V, again, I am beginning with the same type of statement for the first one, first option. Now I am eliminating one vector from S. Now the V was into S from before, I am eliminating one element from S. Will it still be a spanning set?
No.
The statement saying it must be a spanning set of V. Now the statement is correct or incorrect, you have to say. Now the fourth one is, Mihir, can you mute yourself? Yeah. Yeah. Now if S is a spanning set of vector V, again, I am taking union of V. Now first statement was must be a spanning set. The second statement said may not be a spanning set for all V. Okay.
Sir, I am not getting last 2 options. Can you explain it with a sample, sir?
So the third one is saying if you are eliminating one element from your spanning set, will that new set will be a spanning set? That is the
No,
third
sir.
one.
That
Don't tell the answer now. And the fourth one is saying that if you are adding another element from outside, which was not in S, now it may not be a spanning set. I mean, there is a possibility that it may not be. A first option is saying it must be. Basically, first and last option are, I mean, cannot be true together, right? One of them must be true. So this is the four options. These are the four options from which you have to choose. So more than one option can be correct. So I hope you have all written down the option at least in your copy, right?
Excuse me, sir.
Yeah.
So like just I know you explained, but still just to be sure, spanning set meaning like all the sets which can be made from it. Like we are not talking here
So
about the
spanning set of
smallest
V means
possible.
if you are taking any element of V,
Yes.
it can be written as a linear combination of the element of S. Then S is the
Yes,
spanning set. Okay.
It would be like a very large set. It's not we are not talking about the smallest number here, right?
No, it can be anything.
Okay.
Okay. It can be anything. Yeah. We are not talking about basis. Yeah. Right.
Yeah, right. Basis, sir. I keep confusing with that one. Okay, thank
No,
you, sir.
it is just spanning set. Yeah. Okay. So I want all of you to participate in this interaction. Okay. There are 83 people. I want all of you to participate in this.
You are getting
Okay.
a lot of
So,
likes.
that's okay. But only like will not do anything. You have to solve it.
Sir, I'm not able to select.
So can you go to the
Ah,
next slide, sir? I think we can.
I will go to the next slide, then you can give your answer. So I am going to the next slide. Okay, everyone has written down what are the options.
Yes, sir.
Right? Because in next page you will not see the option. There is, I cannot do that. I don't know how. So yeah, now you can post your options. Option 1, 2. So all option got some votes. Now, most of you are saying first option and second option are correct. Some of you are saying third option is correct, and some of you are saying fourth option is correct. Now, I will select someone to explain each option. Okay. So let's wait for some time. Okay. So, yeah. Anyone wants to put your answers still? Okay. So more or less, first and second option are correct. That from the majority of votes, but 3 and 4 also has got some vote. Okay. So first option. So let me see someone. Abdul Hadi. Can you unmute yourself? I mean, can you participate here? No. Abdul, can you hear me? May not. You may not want to participate. Okay. Then any one of you just explain the first option. Why the first option
Okay,
is
sir.
correct or incorrect? Yeah. Who is it?
Yeah.
Who is this?
Srajan.
Srajan.
Yeah. So S is anyway spanning set. So it can span the complete vector space. Adding any other elements from a space, it wouldn't make like any difference to it. So completely it can again span.
Okay. Great. So any doubt in this option? So what I am saying, suppose S is this type of set. Okay.
Sir, can I say in other
Spanning set
words?
of V. Yeah. Go ahead.
Yeah, so as it is written that V will be also element of a span of S. So V can be V dash, I think. V dash, V end.
V, yeah.
Yeah, so V can be written in the form of AV1 plus BV2 plus CV3
exactly,
like that.
Exactly, yeah.
Right? So we can combine both, then we can write AV1 plus BV2 plus CV3 minus V is equals to 0.
Okay.
So we can say that the new set, the S dash will not be linearly independent.
Okay.
So if that will be not linearly independent and it is also present in V, so we can say.
But for being a spanning set, it need not be linearly dependent or independent. I mean, it has nothing to do with that. Because we are talking about only spanning set, not maximal or minima.
Okay, okay. Yeah,
okay?
yeah.
So you don't have to go there.
Yeah, we don't need to do that.
Yeah. But the logic you are giving is correct, but not for this answer.
Yeah, yeah. Okay.
Yeah.
Yeah, got it.
So what is this saying? So if I have any element of V, suppose I have W in V. Okay. So I can write W as a linear combination of these many elements.
Yeah.
Right? That is the meaning of spanning set. Anyone has any doubt in this?
No.
Anyone? No. Okay, good. Now what am I doing? I am adding another element, V. This V is coming from V itself, the capital V. So my new set is V1, Vk and V. New set. Right? Now I am taking any element for V again. Any element. May not be same element, any element. So W, let's take that. So that element has a linear combination, as I have already said. Now for the last one, I can put 0, no issue. So still it is a linear combination, right? Yeah. So the new set, this is suppose my S prime. So new set will also generate all the elements, correct? So S prime is also mean must be. S prime must be linear, must be spanning set of V. It's clear? So I am saying question number 1. This is option 1. Is it clear to everyone?
Yes, sir.
Yes, sir.
Easy? It was an easy question. Okay. Second, span of an empty set is 0 vector space. I mean, that is basically the definition. If you don't have any element, so it will generate 0, basically.
Yeah.
This is just definition. Next, the third one, which is again an important thing. You have a spanning set and you are eliminating one vector from the set.
Yes, yes.
Now, it must be a spanning set of V, but still it will be a spanning set. So, is it correct or wrong? Some of you have given it is correct, and some of you have given it is wrong.
So we can't say.
Sir, if it is a base,
No,
then
you
it is
can't
wrong.
say mean here it is the statement is must be. So if it is
Yeah,
not
so
must
we
be, then
can't
it is
say.
false.
Yeah, it's false. That's what I'm saying. That we can't say. Must.
Right. Any one who want to say it is correct?
It is correct, sir.
Sir, it will be correct. Then the S be base.
Basis.
Basis, yes.
So it need not be basis.
Really,
I think.
Need not be also that thing.
Yeah.
I mean, you are saying S is a basis, then it is correct.
Yes.
That is separate case. That I am not asking. I have not tell you what basis is till this point. I will.
The question, so to option 3 will be correct because we are saying S is a spanning set, and from that we are just deleting. Let us say I am subtracting some values of v vector. Then it will be a spanning set, right? Right, sir?
Spanning set of V. Yeah.
Yes, because I the source of the base set is a spanning one, and from that if I am
S is not a basis. Remember, S is just a spanning set.
Yeah, so the volume the spanning set itself, I'm just removing some of the elements. Then it will be belonging to the S vector. Then it will be a spanning set of V.
So suppose. Okay, anyone wants to say something else?
Sir, in the first option, you said like you're adding V to the spanning set, and the same thing you're subtracting it from the spanning. Still, it is a spanning set, right?
No, now so in this first option, I am adding another vector from outside, right? Which is not in S. Right? Now here I am deleting one vector from here itself. Among this V1 to Vk, I am deleting. Suppose I am deleting Vk. Will it be a spanning set? That is the question.
Okay.
Remember, if you
Sir,
see
the
the question
result,
properly,
sir,
this
the
V is coming
result.
from S. Now this V is coming from S. Here V was coming from V.
Ah,
So different, right?
That's correct. Okay, okay.
Sir, here
So
the question is about. Sir,
let
here
me
the
give an
question is
example.
about.
Okay.
Sir,
So
if the
could you
question.
just explain the difference between V and S once?
V is the total vector space. S is a set of subset of that. So V is the vector space. It is the vector space. Okay. I am taking a subset S,
Okay, so
which is consisting by
any
k
sum
elements.
vectors like from it.
Collecting some vectors from V, I am creating this set.
Okay.
Right? Which span V that is given. Which span V means you take any element of V, you can write V as a linear combination of element of S. That is given. Right? What I have written here. Okay. Now for the first option, I am adding another vector inside that. The question was, still can we write any vector of V as a linear sum of these vectors? Yes, we can, because we can write W as a sum of V1 to Vk itself. So the last element I have added, I can put a 0 in front of that. Right? It will not change anything. So that's why the first option was correct. Now for the third option, suppose in R2, consider R2, a simple example. Some of you have guessed this as a basis, but still could not relate that much. So you don't have to know what basis is for this problem. So my first question is a spanning set of R2. So R2 is my V here. Okay. So is as a spanning set of V. And these you have to answer.
Yeah.
Yeah. Why?
Because again, linear combination of them can give any R2 points.
Is it clear to everyone?
Yes.
Yes, sir.
So any element of this is of the form a comma b. So I can write any element as a linear combination 1 comma 0 plus 0 comma 1, like this. Correct?
Yes.
So S is a spanning set. The answer is yes. Now what the question says, I have to eliminate one of the element from this. So I am eliminating, suppose 0 comma 1. So the new set I am getting is just 1 comma 0. Now still is this new set. So this is my new set S prime. Is
It's not a
S
spanning
prime
set.
a spanning set
No,
of V?
sir.
No, sir.
it is
It
not a
can't be.
spanning set.
Why?
Because it's not complete.
Complete means what?
I mean, we'll
Every
not
second
get
element will be 0. Any
Exactly.
combination of that, it just
Can
give a
you
comma
tell me
0.
one element which cannot be, generated by this element?
the B part cannot be generated.
1 comma 7.
If you take 1 comma 7, it cannot be generated by this, right?
Yeah.
So if B is non-zero, basically any element which is not on x-axis, correct? That cannot be
Sir,
generated by this.
Sir, this is not clear. Can you please repeat this one? Once I delete one element from here, let us say I am deleting 0.
0 comma 1. So I am getting 1 comma 0 as my new set, right?
Yes.
This was my set, right?
Yes.
So I am
From
deleting 0 comma 1. So I am getting 1 comma 0 as my new set, correct?
Yes. Yes.
Now the question is S prime a spanning set of V? I mean, can
yes.
every element of R2 generated by 1 comma 0?
No.
No.
No, right? Because 1
Yes.
comma 0 can only generate the element on the x-axis. Right? Other elements it cannot be generated by this S prime. Correct? So this answer is no. So the statement was must be. I mean, if you see the statement, must be a spanning set of V, it is not correct.
Not.
In some cases is maybe. Right? Suppose I am taking S as 1 0, 0 1 and 1 1. This set. This also span of S is also R2, right? I mean, if I take V as R2, so this is also a spanning set of V. Correct? Because only these two elements is generating the whole set. So whether it is there or not there does not matter. Now, if I eliminate 1, 1, the set I am getting is this, right? This is my new set. Still, it will generate R3, right? Span of S prime is still R2, right? So, in some cases, is maybe, but it not must be, correct?
So this one, after removing this, when I get the S prime, how I will be able to generate that again, all the three elements, because I will be able to
So
generate
now
only.
here it is 1, 0 and 0, 1.
Yes.
So what is any element of R2 look like? A comma B, right?
Yes.
So how we can write as linear combination of these two? This is a linear combination, right?
Yes.
So you can write any element of R2 as a linear combination of these two elements.
Sir, what if we keep 1, 1 and eliminate 1, 0?
Still you can generate in this case.
Sir, that
That
means the
I
third.
showed last time, right?
Sorry.
So first of all, this at least this part is clear, right? If you eliminate 1, 1, the set
Yes,
I am
sir.
getting still it clear, no?
Yes.
Okay. Now, as she is asking, so this is if I eliminate this one, right? What I get 1, 0 and 1, 1. This is S prime. Now, can it generate R2?
Yes.
Yes.
How?
A into 1, 0.
Sir,
Plus B into 1, 1.
But then first element is A plus B, then?
Yes.
sir, 0
A
into
minus
1
B.
comma 0.
Not 0 into, no. If you put 0 into 1, 0, then it will be just B, comma B. Right? So if you calculate this now, what it is? A, comma B, right? It is clear, no? This is A minus B.
Yes, sir.
It is clear, no? So what is first element? This and this. Then A minus B plus B. This is B. This is cancelled out. So it is A, comma B. Okay?
Yes.
Clear? So in that case also we generate R2. So it may be, but it not must be. Okay?
For an exam, we to understand this logic, like A to like multiply by A minus B, that we'll have to gauge the logic, right? For if any other question is given.
I mean, I have shown in the previous session. In that session also you have asked this same question.
No, sir, I did not ask.
Okay, someone has asked. So you can solve it, right? This A, comma B. You are asking that how we can find this A minus B, right?
Yeah, the logic. Yeah.
So logic, you just write it and solve for X and Y. So A, comma B is X plus Y and Y. So what is your equation? This and Y is B. Solve this system. What you will get? Y is B already given. So X is A minus B. Clear?
Yeah.
This is easy. I mean, this you can do it yourself.
May I ask a general doubt is related to the option 1? Yeah. Now, when we say we are actually making a union of the small vector v with the span, span in general covers the entire vector space capital V. That means that small v will be a clone or a duplicate of one of the other vectors in a vector space, correct?
S does not contain all the vectors of V.
Yes, does not contain all the vectors.
It may not be duplicating.
Okay.
Right.
Okay.
S is a subset of V. So I can take some vector outside of it.
Okay.
Right?
All right.
Yeah.
All right. Thank you.
Yeah. So as first option is correct, last option is not correct. Right? I don't have to explain the last option. Correct? Is it clear to everyone?
Yes,
first
sir.
option was must be. I have proved it. It must be. So it may not be a spanning set. It does not make any sense now. Correct?
And third option should be maybe, right? Then it will be correct.
If third option was maybe, then it should be correct. But here it was must be, so it must be incorrect. Okay?
So what is zero vector space?
Zero vector space is just zero. every vector space has a 0 element, right? If you take just 0, suppose you are taking 0, 0, that is a vector space itself, only containing 0 vector.
So it is basically a vector space comprising of only the 0 vector.
Exactly, only one element. Okay?
Yes.
Okay, great. So hopefully this problem will solve your any doubt regarding spanning set. This problem will have the potential.
So,
Yeah.
so what is the meaning of the spanning? Why we do the vector? But now, what is the vector space? We understood that there are the lots of vector. Why do we do the spanning set of the vector space?
To minimize
But
the
the meaning
data.
of
You
the
don't
spanning
for
space.
so basically why we are studying spanning set, we want to find what are the minimum possibility, so that minimum number of vectors, so that I can generate all the vectors from them. So if I only study only those vectors, it will be enough. That's why we are trying to find spanning set, right? Eventually we will find what is the basis that will solve our all problem. So if we only know the basis, we know the vector space.
So in this spanning set, there is only independent vectors.
Not necessarily. This is only spanning set, so it can have. I mean, the set may not be linearly independent. The set may be linearly dependent also. But if the spanning set is linearly independent, then we call it a basis. That is the definition of basis. Then we call it a basis.
Okay, sir.
I will come to that. Okay.
Sir, one more thing. We saw that the vector space R2 has two spannings, can have two spanning sets. The
It
one
has
zero,
many,
zero,
infinitely many spanning set.
Oh, okay.
I have given only two examples. It has infinitely many spanning sets.
Okay.
Okay. Okay. So this problem is fine. Then, okay, this problem. So when we are dealing with vector space of matrix, right? So S is a set of matrices where these three matrices are given. Now consider the following statement. Span of S is a vector space consisting of only lower triangular matrices. You know what lower triangular matrices are, right? What is lower triangular matrices for 2 cross 2? Anyone? What is lower triangular
A2
matrix?
one
R12 should
element
be
is the
0.
only one.
A2
A1
one
should be
element.
0.
A2 one element should not be 0. Other elements should be 0.
Correct.
All the elements below diagonal should be non-zero
elements
and
also.
diagonal.
All the element above diagonal should be 0. That's only the notation. I mean, below whatever that may be. But above the diagonal, it should be 0. That is lower triangular. Upper triangular, all the element below the diagonal should be 0. Okay? Okay. So span of this S is upper triangular. Span of S is consisting of all the square matrices. Span of S vector consisting of all scalar matrices. Scalar matrices mean
Upper triangular, sir.
don't give the answer now. What is scalar matrix? The last option, last statement.
So, but except principal diagonal, all the elements are 0.
All the elements are same. May not be
Yeah,
same.
diagonal elements change.
All the
Principal diagonal
are
elements
same
must be same, and except that others are 0.
Exactly. Correct.
So first matrices is scalar or not?
Huh? No, first matrix is not scalar. Any matrix is not scalar either.
Okay, sir.
All the diagonal elements should be same, no? For being scalar. Okay. So have all of you have seen? I mean, written down this problem. Written down the statements. Maybe already solved. So yeah. Should I go to the next slide?
Yes,
One
sir.
second, sir.
Yes, sir.
Okay. So once you are done, you can just cast a vote here so that I can know how many of you are doing this at least. So once it come to a substantial number, so can I move? Yeah, Nikhil, you want to ask something?
So I wanna ask something. So
Okay.
I have some problems in week 3. The practice assignments और activity मतलब हर lecture के बाद जो questions है ना उनमें कुछ कुछ है जो मेरे को पूछना है. कब ले सकते हैं ऐसा वो problems during this time or after that?
तुम मेरे पिछले 2 सेशन में थे?
Yes sir.
Okay. So using that concept, you still not able to solve those?
A little bit I have confusion sir.
Okay, so at the end of session, can we do that?
Okay sir.
Okay, yeah. I will not solve any problem, but I will listen what you have tried. Okay.
Okay sir.
Okay, so I am moving to the next slide. Okay, you can write your answer now. So first position there is 1, at 2 1 1 2 there is 1, at 2 2 there is 1. So what should be the thing? Yeah, you can cast your vote which statement is correct. Okay. So P has some vote. R has many vote. Okay. Majority of you are giving Q. Okay. Let me go back to the problem and see. Okay. Those who have said that P is the correct option, can you explain why? Anyone who has given P as correct option, can you explain why? No one has given P. Yeah.
So A2 one element is 0 in all the matrices. Right?
Then what it should be?
A2 one element is 0 in all matrices.
Yeah, then what is that? Then it is an upper triangular, right?
So because diagonal and the elements below the diagonal elements, no, they are 0. That's why
0,
the upper
so
triangle
it's
matrix
upper
is.
triangular. So statement Q is correct, right?
Yes, sir.
Is it? Yeah. Anyone wants to say anything regarding this? Anyone? So these are 3 elements, right? Your voice is breaking.
Even S is correct, isn't it?
Yes.
Yeah.
What was S?
Span S is a vector space consisting
Scalar
of only
matrix.
scalar matrices of order 2.
Only scalar matrix.
No, sir.
Is it
Oh,
only
okay.
scalar matrix?
Okay. Sorry. Yep.
No, right?
It contains
So
both.
if I add this is basically the span, right?
Yeah.
Where ABC is coming from real number. So this is the span. So A, B, 0, C, where A, B, C are real number. Now scalar matrices will be a subset of that. That is correct. But not only scalar matrices, right? Here A, B, C can take any values. So it is an upper triangular matrix, right? Set of upper triangular matrix. Okay? Many of you are given the third one as the correct. Why? It does not consist all 2 cross 2 matrix because there it is 0. So all 2 cross matrix means here can be numbers, right? A, B, C, D, some number can be there, but it is not all 2 cross 2. Correct?
Okay,
is it clear,
sir.
everyone?
Yes, sir.
Option C, can you please explain that? Show the option again, please. Option R. Option R.
Option R. Option R is basically all square matrix, right? All square matrix means is this set? I mean, exhaust all the 2 cross 2 matrices? No, right? this matrix is not there. Correct? Whenever there is a non-zero number at this place, this will not be in the span of these three vectors, right? Because this element will always be 0. Correct?
Okay.
Yeah, no?
So it's so as per the given vectors, three vectors, 1 0 0 0, all the three vectors, we are getting the resultant vector is this AB 0C, and it has to follow all the
Don't call it
methods like
resultant. The spanning set is
okay,
basically set
spanning
of upper
set.
diagonal.
Okay, so that has this lower triangular, that element has to be 0 always. If we are taking any of the square matrices, then that is not okay for that.
Right. So it is the set of upper triangular matrix only. Okay?
Okay.
Clear,
Thank you.
everyone? So this is also one problem which we can solve. Many of you have already done it correctly. So yeah. Now we are coming to some place where we can talk about linear dependence and independence. So a vector space is given x, y, z, and there is a relation between x, y, z. How it is related? X is equal to y minus z. That is given. That relation is given. So x is basically, the first coordinate is basically dependent on y and z, the second two coordinates. Eventually, those are also related to x. So anyway, one element will be related to other two. That is the point. Now, four options are given. The first option is saying 1, 1, 0 and 1, 0, minus 1. First check that whether these two vectors are indeed in V. So is it satisfying x equal to y minus z? The first one is satisfying, the second one also satisfying, right? Correct? Are you there? Anyone?
Yes, sir.
Yes.
Correct.
Yes, sir.
So
Yes,
the
sir.
first, these two vectors are inside V, that is clear, at least that part is clear.
Yeah.
Yes, sir.
Yes, sir.
Now the question
Yes,
is, this set is linearly independent set of V. For the second one, again, first one is inside V, second one is also inside V, third one is also inside V, correct. So is this a linearly independent set? That is the second question. Third question is whether this is a spanning set or not, a spanning set of V. And the fourth one is, this one is a spanning set of V or not. So write this down, solve it. So I will wait for this problem for 2 minutes, then I will discuss again. Okay? You solve it yourself. You know how you have to check linear dependence, independence, and you know how to calculate span of a set. So that is.
X plus y x minus z is equal to understand the spanning set.
Yeah, Lakshmi, you want to say something? Lakshmi, you have raised your hand. You want to say something?
Sir, one question.
Yeah.
Sir, when we see a diagonal of matrix, we always see from top left to bottom right. Is it compulsory?
What does it mean?
Like if we say scalar matrix, that means like the 1 1 2 2 and 3 3 should
We
be
generally, that is convention from left to right.
and not like the 1 3 and 2
No,
2
no.
like that.
Generally, its
No,
convention is from left to right.
left to right. Okay. Thank you, sir.
So
Yeah.
it may be stupidity to ask some, but I don't know how to approach this question. Even I solved the full graded assignment of 3, and most of the probably they are right, but I don't know how to approach this question even.
Okay, we'll discuss.
These are the correct, they are
But I have
independent
discussed
set.
how you have to check
What should
linear
I do?
dependency and
They
independency,
are,
right? So, first of all,
yes,
this is
sir.
a subset
But
of R3, right?
Yes, sir.
This is a subset of R3. All these are subset of R3, right?
I'm confused about these things, see how to start the question. And I understand the concept of independent, but when they all the mix now, so I was getting confused.
That's why. I mean, answer this question stepwise, okay? What I am asking. First, tell me, all these are subset of R3?
Yes, sir.
Yes, great. So, if you see the second option, okay?
Yes, sir.
Let's start with the second option. It has 3 vectors, right?
Yes, sir.
Okay. In R3, we have 3 vectors. Now, I want to check whether that is linear dependent or
Yes, sir.
independent. What should I do? I have mentioned. So, if we write
They
this
all
vector
belong
column wise,
to vector space.
don't need
Okay.
that. If you write this vector column wise and calculate the determinant, if determinant is 0,
Okay.
then what?
Okay.
No, if determinant is 0, then what do you get?
Determinant dependent.
Determinant 0 means dependent, determinant non-zero means linearly independent, right?
Independent. Yes, sir.
So, second option you can solve like that. Now, for the first option.
Okay.
Again, you have to check whether this
Okay.
set is linearly independent or not, right? So, there
So
are 2 vectors.
when we have 4 vectors, when we have 4 vector in option 4, then it should be surely dependent.
Exactly.
But now these are 2.
Then when we have 2 vector, then how we can solve? If there are 2 vector, then if one vector is scalar multiple of the other, then it is linearly dependent. Otherwise, it is linearly independent. Now, is the second vector scalar multiple of the first one? You have to check. Don't tell the
No,
answer. I told not to tell the answer, but okay. You have to check, okay, whether one vector is scalar multiple of the other.
So both the coefficients are 0. Then it is
You have checked
independent.
by the equation, right?
I want to ask one short question.
Then it is linearly independent, no?
The one short question.
Naveen, when someone is asking, can you please hold your question?
Yes.
At the end, you can ask. Yesterday
What
also I
about
told
the
you that.
third option C and option D?
So you know how to find the span of a set, right? Okay. So if this one is a spanning set of V,
Yes,
what
sir.
does it mean? You take any element from V. Can you write a linear combination of these two to get that element? Try it.
What elements are?
Any element of V. Any element of V will look like
Any
what?
element of V. 0 1 1 है इसके अंदर 1 0. Okay, we will find
that
1
is
1
any element.
0.
I say any general element. How any general element of V look like?
The equation solved by x is equal to y minus z.
That is the relation given. So what you can say about any element of
The
that?
relation, the vector who satisfied the relation, this one x is equal to y minus z, is the only vector who is.
So the first coordinate should be y minus z, second coordinate y, and third coordinate z.
Okay.
Right? Now, can that type of element can be generated by these two? That is the question. Or
तो
the
सर
last
हम
one.
लोग को भी कैसे पता चलेगा अगर हम लोगों का
कैसे
1 1
पता
0
चलेगा
इंटू
मतलब?
वेक्टर से आ जाता है तो बाकी अदर कोई वेक्टर नहीं आएगा तो हमें कैसे पता चलेगा हाउ टू जनरलाइज दिस थिंग?
नहीं, you are taking any general vector of the vector space.
What
Okay,
is the
when I
general
am
vector?
solving it, you
How,
can again see that. Okay, I will
how
solve this.
higher can other?
I will tell you that. Okay.
Okay, sir.
Yeah. Yeah.
So may I ask?
Yeah.
Sir, suppose some of a set is linearly dependent, then it must follow this condition x is equal to y minus z.
What?
Sir, suppose these two vectors given, they are linearly dependent. Let us suppose they are dependent. Then they must follow this condition x is equal to y minus z. Then only they belong to vector space, right?
Right. So is there any vector which does not follow x equal to y minus z?
It didn't follow
any
it.
vector like that?
Sir, I'm not getting.
Right. I mean, where is your confusion?
Sir, I was supposing that let the two vectors be which are linearly dependent. Then only they belong to this vector space if they follow this condition.
No. All these vectors are in V. You have to check whether they are linearly dependent or independent, or they are forming a spanning set or not. That is your question. All these are happening inside V. All these elements which are given, those are all these vectors are inside V. Because all of them are satisfying x equal to y minus z.
Okay. Element can only belong to this vector space if it follows this condition. Sir, the vector elements can only belong to vector space V if they follow x is equal to y minus z. If they don't follow this condition, then they don't belong to this vector space.
Exactly.
Right?
Correct. Yeah.
Okay. Clear, sir.
Okay, so I am going to the next slide so that you can answer it, then I will solve it. Okay? Yeah, you can put your answer. No one is giving answer?
I'm giving some.
Okay.
Sir, option is not showing in my Mentimeter.
Can you say there is an option called
Yeah,
going to next
now
slide
it's
maybe?
coming. Now it's coming.
Okay, so basically 1 and 3 getting maximum number of words. Option 2 is not getting so. Okay. So more or less all the options are getting good. Okay, so you can put your answer. Then in the meantime, we are solving this. So what this is saying. So let me start with this. So there is a vector space which is a subspace of R3 such that x equal to y minus z, where x, y, z are in real number. So any element of this vector space is basically of the form y minus z, this. Right? I can replace x by y minus z as it is given already. Okay, like this. There can be any other way also. So you can replace z by x minus y minus x. You can replace y by x plus z. Anything you can do. So basically, you can replace one by the other two other, right? Any general form. That is the general form of element in this vector space. Okay. For the first two, we don't really need that. For the first two is 1, 1, 0, 1, 0 minus 1. So 1, 1, 0, 1, 0 minus 1. This set is given. And you are asking, you are asked that whether this set is linearly dependent or independent. Now there are two vectors, right? V1 and V2. Now in R3, two vectors are given. So basically, if they have to be linearly dependent, then one vector must be scalar multiple of other. So basically, is there any C such that happen? is there any real number C such that this hold? Now, if this has to hold, what I am getting, this must be happening, right? So the first one is C equal to 1 and the second
Can
one
you
is C
please
equal to
mute all,
0.
sir?
Yeah, I will. Yeah. And this is giving 0 equal to minus 1. So basically, from here I am getting 1 equal to 0 and 0 equal to minus 1. So all these are absurd basically. So there cannot exist such C, right? Is it clear that there cannot exist any such C so that this happen? Right?
Yes, sir. So this is
So
not
this
a
is not linearly dependent. That means this is linearly independent.
independent.
Is it clear to everyone?
Yes, sir.
Yes.
Okay. This is question 3. Okay. Now, what about option 2? Option 2 is
So
quite easy. There are 3 elements. 1, 1, 0, 1, 0, minus 1, and 0, 1, 1, 1 is added.
So, sir,
So
when
this
two vectors are giving, so easily to see it is dependable or not. It is a scalar multiple of others or not.
yeah. That's I
If it is
am
not,
saying from last day.
Sir,
yes.
yesterday you had mentioned that whenever there are three vectors, they are always independent. They are always dependent because the
In
first two can.
R2,
Okay.
Then it is
this is
easy
in
to
R3.
determine.
If it is in R3, you have to calculate the determinant.
Okay.
Okay? Because that will form a square matrix. No? You write it as column. Right? Now you can calculate the determinant of this matrix.
Sir, can you repeat the option 1?
So for option 1, if it has to be linearly dependent, one vector must be scalar multiple of the other. Right? So my question is
Yes, sir.
this second vector V2 is a scalar multiple of the first vector? So does there exist any C, any scalar, any real number C, such that this happens? C into 1, 1, 0 equal to 1, 0, minus 1. So
Okay.
C is 0 equal to 1, 0, minus 1. That is the equation. So from this, if you equate the third coordinate, you are getting 0 equal to minus 1. And from the first two, you are getting 1 equal to 0. So basically, these are absurd. So there cannot exist such C, right? So the second one is not a multiple of the first one,
Okay,
or any
sir.
real number C.
Yes, sir.
Right? So this set is not linearly dependent. So it must be linearly independent. Okay? Clear?
Yes, sir.
Okay, sir. Okay, sir.
Now, what about the second one? Second one, this is the same given.
Dependent, sir. Determinant
So
is
you have to
zero.
check the determinant.
Determinant is zero.
This matrix is not invertible.
So
It is
determinant
linearly
is 0,
dependent.
is it?
Yes.
They are dependent.
Determinant
These
is zero.
vectors are
Determinant is
linearly
zero, so
dependent.
it's
This
dependent.
is 1, 0. This is
One
This is
minus
why I
zero.
was asking if I can say determinant is 0 because 0 was in diagonal.
So they are dependent, sir.
no.
Because it has
From
infinite
this you
number of
cannot say determinant is 0 or not. No, who is this? Atif? Or no?
Sir, whenever
Who was asking this?
any column or row is 0, that time you can say, right? If any entire row or column is 0, only
Yeah,
then
but
you
by
can
only seeing the diagonal, you cannot see for a matrix.
Sorry, sir. That's a big mistake. That was for diagonal matrix only.
Right.
Diagonal, I missed it.
Yeah.
Sorry, sir.
Correct. So this is 0. So determinant is 0. So it is linearly
Dependent.
So can't we apply that logic CC0 is equal to 0, 1, 1 in the second option?
No, because there are 3 vectors.
So one by one, we can't go like that.
So one by one you can go, but there is a possibility that this third one, which is indeed the case. So here also this second one is a non-multiple of the first one.
Correct.
Sorry. Second one is not a multiple of the first one. Third one is not also a multiple of the first one, right?
Yes, sir.
So if third one is multiple of first one, then saying linearly dependent, linearly independent.
If one of them is multiple of the another one, then it is linearly dependent.
Sir has explained it in very beginning of this lecture.
Yes, sir.
So it can happen that the third one is basically in the span of these two. Now span of these two is not the scalar multiple only. They are linear combination of these two, right? So
Okay,
0,
sir.
1, 1 can lie as a inside the span of these two, which is in this case, right? So if
Okay.
you see that 0, 1, 1, 1 minute. So I think it is 1 into 110 minus 1 into 0, sorry, 10 minus 1, is it? So you can see the third one is basically lying in the span of the previous two, right?
Okay, sir. Thank you.
Yeah. So only checking scalar multiplication of one vector is not enough in this case. Okay.
Okay, sir.
Okay. So the second option is also correct. Yeah.
Sir?
Any question? Anyone is asking something?
Sir, in the second one, actually we calculated the determinant and determinant became 0. So we said it is dependent, right?
That's enough. That's enough.
And sir, like one more thing you told about in between that R2, if it is R2, we need to calculate, and if it is R2, that and it is so that we will say that all the three vectors are in dependent. If it is in R3, but if it is in R2, we need to calculate. Is that the correct one? My understanding? Or
what again? Can you repeat? I mean, your voice is breaking a little bit.
so in R3, so if there are three vectors given to us, and if it is in three, then we know that it is linearly dependent. But if it is
If it
in
is in
R2, then
R2,
we need to calculate to determine.
no. If it is in R2 and you are given 3 vector, I mean in R2 you have more number of vectors than 2. Then it is linearly dependent.
And in R3, we need to calculate that.
In R3 you have to calculate the
determinant.
determinant if you have 3 vector. But if it is more than 3 vector, then again linearly dependent. Okay.
Okay.
Can you go above on the set representation you have shown? From that also we can say, na? Y minus Z, Y comma Z. From that set representation, we can also say this last two vectors is dependent on the first.
No, this is the vector space. I mean, from here, how can we say? All these 3 vectors are coming from this vector space, but from it, how can you say whether these 3 are dependent or independent? No.
Because from that set representation, you can say last two vectors Y, Z is the first vector is dependent on.
This whole thing is a vector, not only Y, Z are vectors.
Okay.
This whole thing is a vector. This is like
Okay.
something 1, 2, 3 type of thing.
Correct.
Okay.
So option 2 is incorrect, right?
It is linearly dependent. It was linearly independent. So it
Yes,
is
incorrect.
now this one 0, 1, 1 and 1, 0, minus 1 spanning set of V. So basically these two element, right? So option 3, 0, 1, 1 and 1, 0, minus 1, right? Whether this will span our V or not. So what was our V? Y minus Z, Y, Z. This is the representation, right? So if I take any element, can I write it as a linear combination of these two? That is the question, right? Is it clear? At least the question is clear.
Okay.
So this, can we get any A and B like this so that it holds, right? So what are the equation I am getting? These 3 are the equation. So anyway, I am getting some A and B. A is Y, B is Y minus Z. And what is A minus B? Is it Z? Yeah. So basically this is satisfied. So if I solve these three equations for A and B, the solution is A is Y and B is Y minus Z. This is the solution. So I can write Y minus Z, YZ, which is any element. So depending on the value of Y and Z, it can represent any element of V. I can express this as Y into 0, 1, 1 plus Y minus Z into 1, 0, minus 1. Okay. Is it clear to everyone? So it is the spanning set of V. Is it clear, everyone?
So, because it was linearly independent and still they were part of that, maybe that made it spanning set, isn't it?
No, but I mean, no and yes both, because if you know what is the basis of, I mean, what is the dimension of V, then you can tell it.
Okay, in this
Because
case, it's we not clear whether it's
dimension
RT.
is, here in this case is clear. I will tell you, not today, maybe tomorrow, that this vector space has dimension 2, basically.
Dimension
Because
2.
dimension 2.
Okay.
And if it has dimension 2 and there are set of vectors, linear independent vectors which have dimension, I mean, cardinality 2, then that set must be the spanning set, because that is a basis.
Okay. Thank you.
So that I will explain tomorrow, but for today we can directly see it at least.
Okay, sir.
May I ask a question?
Yeah.
So when you say a spanning set, it is the entire set of possibilities that are covered. Is that a correct statement with two independent
span
vectors?
of some vectors means all linear combination, all possible linear combination.
Okay. So there cannot be two spans for same set of vectors. It's only one span.
I mean, spanning set is, I mean,
Only
span
one.
of some
Okay.
set is basically a single set.
Okay,
Vector
got it.
space.
All right, thank you.
Sir, may I ask you a question?
Yeah.
So here you have said that first option is incorrect, right?
I forgot. First option is linearly
Correct,
independent, so it's correct, no?
Okay,
Correct.
okay, sir. Okay.
So just for understanding purpose, is it possible that for option 3, can you give an example? There are two elements and they are part of this vector, but they don't form a spanning.
No, this
They are
is not
not. They are
possible.
linearly
That's why that's
independent.
not. No, that is
Sorry.
not possible.
Okay.
It will always be like that because its dimension is 2.
So okay, because that
That's
will
what I am
learn
telling
tomorrow.
you. Yeah.
Understood.
Yeah. So this span the whole set, span B, this set 0, 1, 1 and 1, 0, minus 1. This span B, is it correct? I mean, is it clear to everyone?
Yes, sir.
Sir, we can prove the other way, sir. The simple addition, then check the format is fulfill this or not.
How?
The simple add the two vector and then check this
No, that will
above
not
condition
solve
is
your
fulfilled or
purpose.
not.
No, if you just add these two vector, you will get a new vector, right? Like this, which
Then
satisfies
I
this
check this.
equation.
Yes, sir.
Which satisfies this order, but that does not do anything because that has to be, because these are vectors in this vector space. Once you add this, it must be lie inside the vector space. That was the first condition of vector space, the definition. So it shows nothing, right?
Okay. So dimension 2 means one element is always 0, the vector. Out of 3,
No,
1
no,
is
no. That is not true.
Sir?
Dimension means cardinality of basis. And what is basis, I have not described yet. So today I am not going to do that, because that will create more discussion on that line. That I will do tomorrow. Is that okay?
Yeah, okay.
Sir, here after calculating the value of A and B, how do we conclude that they are dependent or independent? Is the how can you please?
No, I am not checking dependency or independency here. I only am interested. No, option of spanning set of V or not. This is the third option I am doing. This is spanning set of V or not. So I really don't need to know whether these are independent or dependent.
Okay, so then after calculating the value of A and B, how do we say that it is a spanning of that? Because it has some values.
Yeah, some values. So basically I can write this general form of vectors in V. So general form of vectors means how the element look like in V. Okay, any general element will look like y minus z, y comma z.
So then how did you do the 1 0 minus 1 here? Like I really did not get this last line, which you have written y minus z.
These two vectors are given, no? 0 1 1 and 1 0 minus 1.
So the last line, can you please explain this last line? I did not understand that. Y 0 1 1 plus y minus
this is the set given.
Okay, okay. A and B from you just multiplied the A.
This is my V1, this is my V2. Can I write any general element of this vector space V as a linear combination of V1 and V2? Can I write a V1 plus a
Yes, sir.
V2? V2.
Yes, sir.
Can I write that? So I have to solve A and V, A and B. What was my V1? V1 is 0 1 1. What was my V2? 1 0 minus 1. So basically I write it down. I have got some equations and I'm saying that there is a unique solution, that is A equal to Y and B equal to Y minus Z. So basically there exists some AB, right? And I have written that. So this is my A is Y, B is Y minus Z. This is my V1, this is my V2. So really I can write any element of V, any element of V as a linear combination of this V1 and V2. That's why this S is a spanning set of V. Is it clear?
Sir, I'm not getting convinced. Like just I understood the value after I calculated the value of A and B, and also I understood the vector V1 and V2, which is 0 1 1 and 1 0 minus 1, and I'm just writing in the form of A into vector V1 plus B into vector V2, and that is what only I wrote it here. But how do I ensure that okay it is I will get the solution once I write that?
First of all, you tell me what we have to do here. Do you understand that?
We are just telling whether it is a span of the existing that vector
We
V or
find
not.
the value of A and B. If we're putting Y and Z, so we find the value of A and B, so we can span.
So the question is, by using linear combination of V1 and V2, can we write every element of V? Okay, that is the question, right?
Okay. I did not have the question. Okay, sir.
No,
The question
I
is
mean,
only to okay.
question is S spans V? That is the question, right?
Okay.
I mean, that is the option. That is the option, no? This one, third option I am doing.
Yes.
This is my yes.
Sir, in
Okay.
this option,
No,
we can
I am not getting where is your
No, sir.
doubt?
Actually, I got confused whether I need to calculate something or not, or whether I am just wrote the equation, but I did not calculate anything. But how do we ensure that it is? I'm
Forget
reaching the.
it. What you have done, forget it. Have you understood what we have to solve for this option 3?
Yes, sir.
What I have to solve?
I need to find out the value of A and B.
No, before that, what is this option 3 saying?
Option 3 says that I need is it a spanning set of V or not? I need to find out that.
Correct.
And A is your spanning set given 0 1 1 and 1 0.
No, that is S is the set given. I have to show whether S spans V or not, right?
Yes.
Is this part clear at least?
Yes, sir.
So for that, what I have to do? I have to take any element, any general element which is of this form, right? This is the general form of element in V, correct? Y minus Z, YZ, correct?
Yes,
sir. Can I write this as a linear combination of these two vectors, which was in S, right? The vectors of S, correct? Till this part it is clear?
Yes, sir.
Okay. So when can we write that? When I can find a value for A and B.
Yes.
Right? If I can find the value for A and B, I am done.
Then it is a span or not?
Correct? This is clear?
Yes, sir. Yes, sir.
Yes.
Now I got. Yes, sir.
Okay. So I just write it. I write down the equation, what is basically A into this and B into this. So I getting this. I am equating with this general form. So I am getting these three equations. And by solving this, I am getting A equal to Y and B equal to Y minus Z. Right? I mean, solving it, this is quite clear. Right?
Yes, sir. Yeah.
So basically, I have values for A and B. A is Y and B is Y minus Z.
Z.
So I can write any element of V as a linear combination of 0, 1, 1 and 1, 0, 1. Correct?
Yes, yes.
So that means this set 0, 1, 1 and 1, 0, 1 spans V.
Okay. I
Yeah?
misunderstood the question, sir. Okay. Thank you, sir.
Now is it clear?
Yes, sir.
Yes, sir.
I got.
Okay, great.
Sir, if I could not any value for A or B, then it not be a spanning.
Then then it is not spanning V.
Oh.
Sir, so the value of A and B always have to be in terms of Y and Z, right? Because
I mean, in terms of this general form of element. That will
which is given on the left-hand side, LHS.
Right.
Sir, can I ask you a question?
Yeah.
So in the beginning, I asked you a question. I hope you remember that that method, second method example. I did not understand. Actually, I have a class again from 8 o'clock statistics class. So can you discuss, if you won't mind? Sorry to interrupt in between.
What was that? I mean,
Will you allow me to share my screen? It is just a small doubt.
Yeah, but at least tell me, then I can.
Actually, after deleting, sir has taken a span, means a set where 100, 120, 103, 203, and
week 4 is it?
Sorry?
Week 4.
No, yeah, week 4, 4.2, lecture 4.2. Can you go to the last?
1 minute, it will come probably.
After 14 minutes, actually, it is a 15 minutes video. Yeah, so this is the doubt here. So after deleting 0 to 3, how sir has got that S2 value as 100, 110 and 101?
So what was the set earlier?
Can you go back, sir? Yeah, earlier set was S is equal to this.
So by 0 to 3, you should get 100, 120 and 103, right?
Yeah.
120, 103, 100. Okay. I think he has made a mistake here.
Yeah, so answer must be
he has made a mistake here.
Yeah, answer must be 120, 103, 100, right?
Right.
Okay.
Yeah.
Okay, sir. Thank you so much.
Yeah. Okay. So let's come back here. What about the fourth option? Is this a spanning set of V?
Yes, it is. It is also a spanning set.
No, sir. So we cannot find the spanning of only single element.
So this is only 110, right? And our general element is Y minus Z, YZ. Right? So suppose I am taking 0, 1, 1. This is an element of this V, right? Correct?
Yes.
This is the element of V, right? Is it clear to everyone? This is
right.
V.
Yes, sir.
Yes, sir.
Can we span, can we get this element by this? No, right?
No.
What is span of this? Span of this means the A into this, right? Where A is any real number. So basically, all the element of this form. So last coordinate is anyway 0. So here it is
third one is
so I
missing.
cannot get. So this is not spanning our set, right? So this is option 4. It is not correct. Clear?
Yes, sir. So option 4 is not correct, sir. Right? Sir?
It is not a spanning set. Yeah.
Yes.
Clear, no?
Yes, sir. Now it's very clear.
Yes.
Thank you, sir.
Okay. Yeah, so should we stop here or you have other class also, no?
Yes, we have a statistics class starting in actually now.
Would you be
So we
discussing
can
something
continue
about
from
basis?
here tomorrow if you would like.
Thank you.
Anyway, we have discussed many things today.
Yes, sir. Yes.
Sir,
Thank you, sir.
would you be discussing something about basis?
Tomorrow we will discuss them. Because
And
this
sir,
problem needs basis.
Yes, sir.
So
Kindly
we have to
discuss
discuss.
tomorrow, sir.
Thank you and good night.
sir, tomorrow can you also please show in GeoGebra how to visualize these, if possible, if time permits, sir?
That's the main issue. If time permits, I mean, I
Yeah,
have to
sir.
do all
And
this.
sir, I don't know if there is a tutorial to see how to visualize it in GeoGebra, but if I know, I can do it myself, sir. I can put
Okay,
the
so
vector.
can you see some of my live session from the previous term?
I've missed all live sessions before, so sure,
No,
sir.
previous term.
Previous term, sir. Okay, sir. Jan term.
So yeah, I can. Okay, I can put something in what is it? Portal. I will put something in portal for that. Okay.
Okay, sir. Then what I will do is I'll post a question in the portal, and if you could respond to it, how to
That will be
the
also
link.
okay. You can post in discourse and I will answer
Thank
that.
you so much, sir. Thank you.
Okay.
So where can we get the link for your previous terms
In
live
YouTube, it
sessions?
should be there. In YouTube, it should be there.
So could you please help us to get those links because
Yes, please.
Okay, then I will find some links and post it in discourse maybe or in
Yes,
portal.
please. Yeah.
Sir, I've shared one in chat. It was okay.
Okay, you have shared something. Which live
Sir,
session is it?
hello, sir.
Okay, you have shared something. Yeah.
Sir, what is the syllabus of quiz 1 up to week 4?
Yeah, up to week 4.
Okay.
Yeah. So tomorrow, I think tomorrow we will finish at least concept of week 4. Let's see.
Sir, if you post it on Discourse, how can we access it by searching your name?
Yeah, by searching my name, I will post it as maybe live sessions. Then you can
Okay.
search the tag live session, you will get that.
Okay, sir. Thank
Okay.
you. Yeah.
Okay. So great.
Can I ask my questions now?
Yeah, you wanted to discuss about practice assignment, is it?
Activity assignments.
Okay. 1 minute. Let me.
Sir, only one doubt, sir.
Yeah.
Sir, zero vector in a vector space is always be only one, or maybe there is more than one, or maybe zero vector is not present in the vector space. That is also possible.
No, zero vector must be inside a vector space. That was the definition, no?
Okay.
Don't forget the definition.
Okay.
Okay. Zero vector must be there anyway. Yeah. Yeah, you can ask what is your.
So, activity 3.1, question number 10.
Okay. Let me find that. You will solve it yourself. Today I have done it, no? What is your doubt?
I'm confused when the similar options are there, or after I'm getting the solution, there is like okay. ठीक है समझ में आ गया. But when these kinds of options, I'm continuously making a mistakes. अभी I don't know, but I can't do that question that time when I'm solving.
No, if you see the statement P, first statement, A square equal to A, right? You have to check whether it is a subspace of M2 cross 2R or not, right? The first statement I am saying, right? Are you there?
Statement, yes. Yes, sir.
So for the first statement, you have to check whether this W is a subspace of M2 equals to R or not, right?
Yes, sir.
So for checking a subspace, what you have to check?
All the elements of lie into M2 cross to R.
That is for subset. That is anywhere there, because in the set it is mentioned that all the elements are coming from M2 equals to R. That is not an issue. What are the conditions for being a subspace?
Then
Yeah.
A square is equal to A. That is the condition.
That is the condition for an element being inside the set. But I am asking, when you have to check some subset is a subspace, what are the condition you have to check?
I don't know, sir.
Then how
The
can
one
you
where
solve
0
this
is
problem?
there and it should be subset of A, that one, sir.
Yeah, correct. So in my last live session, I have mentioned that. If you see that, you can know that. So first condition is 0 vector is inside that or not. Second condition is if I am taking 2 vectors from W, whether the addition will be inside that or not,
and multiplication.
Scalar multiplication will be inside that or not. Correct?
Yes, sir.
Have you seen it?
Yes, sir. I saw all the tutorials, lectures, and all.
No, when I asked you, say that you don't know this.
सर यहाँ पे याद नहीं आता कि ये सबस्पेस के लिए ये चीज था वो चीज था. I'm
तो
getting
तुमने चेक कैसे किया?
वही तो कह रही हूँ सर. मतलब आज का क्वेश्चन इंडिपेंडेंट इंडिपेंडेंट था. I solved the week 3 assignment, graded assignment, but जब आपने क्वेश्चन डाला सब ऐसे कंफ्यूज था कि अभी क्या करना है. मैंने सारा एलिमेंट्स को जो आपने 1 2 3 4 क्वेश्चन नंबर 3 था उसमें सारा चेक किया कि ये वेक्टर स्पेस से लाइक कर रहा है कि नहीं कर रहा है. बट I don't know कि वो independent और dependent. फिर आपने याद दिलाया, then I get to know. All the time I'm getting confused between these subspace and subsets.
Now suppose this is the set given, no?
Yes, sir.
M2 plus 2R such that A square equal to A. Now I have told you what you have to check and what is the set. Now can you check whether it is a subspace or not? What is the first step?
Zero. We will take the zero in A.
So zero matrix है W में?
Yes, sir.
Zero matrix A, because 0 square is equal to 0, right?
Yes, sir.
Okay. So first condition holds. This one holds.
Okay, sir.
What about the second condition? If we have two matrices A and B inside W,
okay.
Question is A plus B है कि नहीं, है ना?
Okay, sir.
So A matrix A मतलब A square है.
Yes, sir.
A square equal to A and B matrix means B square equal to B.
Yes, sir.
Correct?
Yes, sir.
Now A plus B square इसका क्या मतलब है?
A square plus B square plus 2AB.
नहीं, ये मैट्रिक्स है, मतलब ए बी और बी सेम नहीं भी हो सकता. दिस वन ए बी और बी सेम नहीं हो सकता ना.
Okay, okay.
Now we know this one is in W.
Yes, sir.
This one is in W, but we don't know about this one, right?
Yes. Then it
So
will
it
be
may or
not
may
the
not be in
subspace
W.
of B.
So ये subspace नहीं है.
Okay, sir.
है ना? Is it clear?
Yes, sir.
Okay. So well, you can check with some example if possible, that if we have two examples of A and B, the third one may not be there. That you can
Okay,
check.
sir. Okay, last now I will do the next with the 3 statements. Next question is 3.2. Last 4 question में but confused with the adjective way of doing.
So basically A v equal to 0 for all V implies A equal to 0. Is it true or false? First, this question is right. So for all V, this is 0. What does that mean?
Wait a
Like,
minute.
is it saying that the 0 element for all vectors is 0?
No, it is saying that when I am getting a scalar,
yes, sir,
and I am multiplying it with any element of my vector space, it is giving me 0. Then what should be the scalar?
0.
Huh?
0
it should
itself.
be 0. But why?
Because V is non-zero.
V can be any vector, so V can be a non-zero vector. So
Yes,
when
sir.
I am multiplying a scalar with a non-zero vector, if it has to be 0, then the scalar must be 0. Correct?
Yes, sir.
That is the logic for the first one. What about the second one?
A belongs to
Here,
real number.
हाँ,
तो
A कोई भी real number है.
तो सर A also A can be 0 ना?
A can be 0. A कोई भी real number है. A भी equal to 0 दिया हुआ है. ठीक है. A भी equal to 0 दिया हुआ है for all A. मतलब A कोई भी real number हो सकता है.
Correct.
अभी भी 0 है कि नहीं ये प्रूफ करना है. A कोई भी real number हो सकता है मतलब 1 भी हो सकता है ना?
Yes, sir.
So 1 into V you know ना V.
Is 0.
So V equal to 0. Yeah.
Yes, sir.
Okay. What about the third one?
Then C belongs to R and PW belongs to.
Third one तो basic axiom ही है.
So it does not belong to the CV and it is the correct statement, right?
Not equal, you are saying.
Yes, sir.
Is it? Why?
So why? Because we take V vector is equal to 2, 1.
CV minus W equal to CV minus
CW.
This is given, right?
Yeah.
So what is CV minus W?
CV.
So can we write this as this? Okay.
Yes, sir.
Basically, this is minus W, I want to say.
Yes, sir.
Inverse of W, additive inverse. Okay. Now, there is an axiom which is saying I can distribute this, right?
Yes, sir.
Okay.
Yes, sir.
Now, here, this is C into minus 1 into W, right?
Yes, sir.
Now, that I can put as minus 1 into CW.
Yes, sir.
सब वेक्टर स्पेस का एक्सियम ही यूज कर रहा हूँ. ठीक है. Now this plus into minus 1 means minus CW.
Sir, I solved it like कि मैंने वेक्टर V को लिया 1 2 and W को लिया 3 4 ऐसे.
W को 3 4 हाँ ले लो. प्रॉब्लम नहीं है. C
फिर ये वाला चीज माइनस करने पे वो सेम सॉल्यूशन थोड़ी ना देगा. C को कुछ भी न्यूमेरिकल वैल्यू ले लो.
वो सेम नहीं देगा.
I think मैंने
V minus W क्या है?
V minus W minus 2.
Okay. अभी C into V minus W मतलब minus 2C minus 2C.
Yes, sir.
Right? ठीक है ना?
Yes, sir.
Okay. Then what about इस साइड में करता हूँ. CV क्या है?
CV होगा 1C 2C.
हाँ, C 2C. CW क्या है?
3C 4C.
हाँ, अभी माइनस करो.
minus 2C and minus 2C.
हाँ, कहाँ पे गलती किया था?
Overthinking में.
नहीं, शायद तुमने सोच लिया कि ये इक्वल नहीं होगा, तुमने किया नहीं.
I don't know, sir. But little mistakes I'm doing. I know.
Yeah. So last वाला मैं नहीं कर रहा हूँ, तुम कर लोगे आप last वाला.
Okay, sir. Okay, 3.3 का question 6. Why we don't write V2 as an V1 plus V3 plus V4?
कौन सा क्वेश्चन?
Question number 6.
हाँ. So V is a vector space. V1 is a combination of these three. Then कौन सा ऑप्शन पूछ रहे हैं?
Why we don't write V2 as an V1 plus V3 plus V4 like first one.
First
sir.
option. First
Yeah.
option. हाँ. So V2 is a linear combination of V1, V3 and V4. ये गलत क्यों है ये पूछ रहे हैं, यही ना?
हाँ.
अच्छा.
हाँ sir, same doubt here.
So V है A V1 sorry V
V1
V1 है A V2 प्लस VV3 प्लस CV4, राइट?
यस सर।
अभी V2 को लिख सकते हैं कि नहीं, ये पूछ रहे हो, ठीक है?
हाँ हाँ
ABC कोई भी रियल नंबर है?
यस सर।
ओके, सपोज ए 0 है,
यस सर।
सपोज ए 0 है, ठीक है? तो V1 क्या है? ये वाला है, ठीक है? आप क्या V2 को हमेशा V1 V3 V4 में लिख सकते हो?
समझी नहीं फिर से।
नहीं सर, नहीं देख
अभी
सकते।
अभी अगर A 0 है तो अभी क्या तुम V2 को V1 V3 V4 के कॉम्बिनेशन में लिख सकते हो?
नो सर।
No. So there is a case where you cannot do it. If A is non-zero, then you can do it because you can take on the other side, right?
Okay.
If A is non-zero,
यस सर।
then तुम वो कर सकते हो, A V2 को तुम लिख सकते हो V1 माइनस V3 माइनस CV4, जो
इफ एडिशन में ये इफ एडिशन में लिखा होता कि a is not equal to 0 then we can write.
हाँ, then you can write because then you can divide by A, right?
Okay. Okay sir.
You can divide by A, but A 0 हो गया तो ये डिवीजन पॉसिबल नहीं है ना, तो तुम
So
लिख
why
नहीं
we
सकते।
are writing in the third option V2 is the linear combination of V2 and
Yeah,
V4.
this is always true, no?
Logic, I don't know the logic behind this.
No, V2 is always a linear combination. I mean, linear combination means what? There should be some scalar so that we can write it. So the scalar is 1 here.
Okay, that's simple.
Right?
Okay.
ज़्यादा मत सोचना, तो सब सिंपल ही है।
Okay, in the same activity 3.3, question number 3, y130 and pi e0 are options.
ये मैंने कल डिस्कस किया था, थोड़ा कल का लाइव सेशन देख लेना, ठीक है?
And
ठीक है,
question
मतलब
number
इसमें क्या डाउट क्या है तुम्हारा?
कि हम लोगों ने पाई e0 एंड 130 को कैसे लिया?
अच्छा, लास्ट वाला ऑप्शन में
एंड थर्ड सी।
हाँ, मतलब सी तो हो ही जाएगा, बाकी नहीं होगा या होगा, ये तुमने कैसे डिसाइड किया? 1 to 0 को कैसे डिसाइड किया?
ये बट हाँ, आई डिड द कैलकुलेशन समथिंग।
हाँ, 130 भी कुछ कैलकुलेशन से हो जाएगा शायद।
मेरा आया नहीं था सर, मैंने इसको रॉन्ग किया था, दैट्स व्हाई मैंने इसको प्रॉब्लम में डाला।
अभी आ गया तो
सर ये कब सॉल्व किया कल आपने?
कल सॉल्व नहीं किया, मैंने बोला था शायद, सॉल्व नहीं किया था। क्या क्या लाना है? 130 लाना है ना?
यस सर।
हाँ, तो कैसे सॉल्व करना है?
ए बी, ओके
हाँ,
सर।
सो 2a 3a प्लस b, ए वाला ना? So
A is
basically
equal to
2a
1 by
equal
2
to 1 and 3a plus b equal to 3, correct? So a equal to half, so 3 by
B is
2
equal to
plus b equal to 3, so b equal to 3 minus 3 by 2, so 3 by 2.
3 by 2.
तो सॉल्व हुआ ना?
Yes sir.
We can't.
तुम्हारा क्यों नहीं हुआ था?
सर एस रियल पार्ट
ऐसा वेक्टर लेना है ना जिससे मैट्रिक्स से का ये डिपेंडेंट वाला आ जाए, मींस डिटरमिनेंट 0.
हाँ
sir, we have to find a vector which if we add to the above set the matrix will become
हाँ, कर सकते हो,
non-invertible,
प्रॉब्लम नहीं
right?
है। हाँ,
So we,
एक्चुअली
sir,
वही
we
करना बेहतर है, वही एक्चुअली करना बेहतर है।
Because the third vector we can see is 0, so all those where the third vector is 0 will
हाँ,
automatically make the
हाँ। बेसिकली इसका लॉजिक में कुछ और बता सकता हूँ, लेकिन तुम कंफ्यूज हो जाओगे तो उसलिए बता नहीं रहा हूँ अभी। तुम
सर
ये
ट्राई
पहले
करो,
तो
क्या पता इजी हो जाए हम लोगों के लिए।
पता नहीं ये 230 है और 010 है ना, ये दो वेक्टर है और एक वेक्टर है जो इसमें होना चाहिए। अभी तुम सिर्फ पहला वाला कंसीडर करो, 23 और 01, ठीक है? लास्ट वाला तो दोनों में ही 0 है ना?
यस सर।
ये दो बेसिकली पूरा R2 का स्पैन है ना? ये दो पूरा R2 को स्पैन कर सकता है। तो बेसिकली पहले मतलब इसमें तुम ABC अगर लोगे तो AB कोई भी रियल नंबर हो सकता है, ये 0 होना चाहिए बस। इस तरह का कोई भी फॉर्म आएगा तो भी हो सकता है, ए बी कोई भी
सर
रियल नंबर हो
कैसे
सकता
पता चला कि ये R2 को स्पैन करता है?
वो सॉल्व करो, इसको एक्स वाई ले लो या फिर ए बी ले लो, अभी सॉल्व करो ना। ठीक है, तो 2x इक्वल टू ए एंड 3x प्लस वाई इक्वल टू बी, तुम्हें सोल्यूशन मिलेगा ना? हाँ
यस यस।
हाँ, तो y इक्वल टू बी माइनस 3a/2, ठीक है।
ओके सर, 3.4 का 7।
हाँ
3.4 का 7 क्वेश्चन।
इस तरह से नहीं होगा, तुम खुद करो अभी।
सर थोड़ा सा
नहीं नहीं तुम करो अभी, अभी और नहीं करो।
7 का ए डी ई ऑप्शन क्यों नहीं है? 3 पर्टिकुलर
3.4
ऑप्शन,
का
7 क्वेश्चन में ए डी एंड ई।
3.4
3.4 का 7 क्वेश्चन।
3.4 में 7 में ए, तुम दूसरा कुछ बोल रहे हो सर।
ये 9 में होगा, फिर किसमें से?
3.7 में तो ए है, 3.4 का 7 में नहीं।
सर 9 में देखना सर, 9 में है क्या इतना सारा ऑप्शंस? मे बी आई मिस्टेक इन द नंबर।
ये वाला
हाँ
खुद करो, ये मैंने बता दिया है।
ओके,
ये मैंने सच में बता दिया है
कल वाले सेशन में सर।
हाँ हाँ हाँ, ये प्रॉब्लम लेके नहीं बताया है, लेकिन कैसे चेक करना आज भी बताया है ना, जब स्टार्टिंग में।
ओके सर, मैं आई विल ट्राई अगेन। 3.5 का 10
और
and
नहीं, तुम अभी सॉल्व करो, तुम ऐसे करके सारा एक्टिविटी बोल दोगे, नहीं होगा। तुम खुद सॉल्व करो, ये सच में ये अच्छा नहीं है, तो तुम खुद सॉल्व करो, अगर फिर कोई डाउट हुआ तो पूछो, ठीक है। तुम थोड़ा ट्राई करो, अभी तो बहुत सारा कॉन्सेप्ट
डाउट्स ना सर।
नहीं, अभी तो बहुत सारा कॉन्सेप्ट समझ में आ गया ना, एटलीस्ट क्या डेफिनेशन है, क्या कॉन्सेप्ट है, कैसे करना है, कुछ प्रॉब्लम मैंने बता भी दिया कैसे करना है। अभी तुम खुद से ट्राई करना, नहीं तो मतलब नहीं होगा, एग्जाम में भी नहीं होगा, है ना।
ओके सर आई एम कंफ्यूज्ड इन द स्पेलिंग एंड द बेसिस, एंड कोई गाइडलाइन मेरे को वीक 4
बेसिस
इजी
में
हो
कल
जाए।
बता दूंगा, कल का सेशन में आना, बेसिस में कल बता दूंगा, ठीक है।
ओके सर,
बेसिस में अभी तक
सो
बताया
मच
नहीं।
सर, थैंक यू सर।
हाँ
सर जस्ट वन क्वेश्चन, हमने जो लास्ट क्वेश्चन किया था उसकी सेकंड ऑप्शन में वी फाउंड दैट इट वाज लीनियरली डिपेंडेंट, क्योंकि हमने उसका डिटर्मिनेंट निकाला था, वो 0 आया था।
हाँ,
तो हमें कैसे पता चला कि डिटर्मिनेंट 0 है तो वो लीनियरली डिपेंडेंट होएगा?
ये तो कल एक्सप्लेन किया ना, वो जो लीनियर इक्वेशन आएगा उसका सॉल्यूशन नहीं है। कल का सेशन में थे तुम? हाँ थे ना तुम?
हाँ जी सर।
हाँ तुम थे, तो कल का सेशन में पता है ना वो कैसे,
कि अगर डिटर्मिनेंट नहीं है तो सॉल्यूशन नहीं है।
नहीं मतलब क्या कर रहे थे हम लोग, सपोज किस तरह से, मैं 2x2 का एग्जांपल लेता हूँ, ठीक है।
नहीं बन सकती है,
2x2 का एग्जांपल लेता हूँ, ठीक है। 1 2 और सपोज भी कुछ -1 5, ठीक है। इसको चेक करने से ऐसा आना चाहिए, तो ए बी का सॉल्यूशन के ऊपर डिपेंड करेगा कि लीनियरली डिपेंडेंट है या इंडिपेंडेंट है।
जी
सो a माइनस बी और क्या है 2a प्लस 5b, राइट। 0,0
जी।
सो बेसिकली दो इक्वेशन आया था, ए और ए, ठीक ना। अभी इसको मैट्रिक्स रिप्रेजेंटेशन में लिखोगे क्या आएगा, दिस वन, राइट।
यस
इसका कोएफिशिएंट मैट्रिक्स। अभी ये जो इक्वेशन है ये x इक्वल टू 0 फॉर्म का है ना,
जी
x यहाँ पे a b है,
राइट।
अभी इसका सॉल्यूशन, यूनिक सॉल्यूशन कब होगा, यूनिक सॉल्यूशन कब होगा, जब ये इनवर्टेबल होगा।
0, हाँ जब डिटर्मिनेंट 0 नहीं होगा,
जब डिटर्मिनेंट 0 नहीं होगा, एग्जैक्टली। अभी ये मैट्रिक्स क्या है, इसको बेसिकली कॉलम वाइज लिख दो तो
हाँ
ही
जी
तुम्हारा ये मैट्रिक्स बन जाएगा ना।
यस
तो इस मैट्रिक्स का डिटर्मिनेंट 0 अगर नहीं हुआ तो ये सॉल्यूशन 0,0 है, तो बेसिकली ये दोनों 0 है, तो लीनियरली इंडिपेंडेंट है।
अगर इसका, सॉरी कुछ आप एक बार दोबारा रिपीट करेंगे, अगर इसका सॉल्यूशन नहीं हुआ तो
अगर इसका डिटर्मिनेंट 0 हुआ तो, डिटर्मिनेंट नॉन 0 हुआ तो क्या होगा,
सॉल्यूशन
तो सॉल्यूशन है, सॉल्यूशन है।
और सॉल्यूशन क्या है? यूनिक सॉल्यूशन होगा तो सॉल्यूशन है क्या?
यूनिक सॉल्यूशन कुछ भी हो सकता है कि दोनों जीरोस भी हो
ऐसा
सकते हैं, नॉन जीरो भी हो
यूनिक
सकते
सॉल्यूशन मतलब सिर्फ जीरो ही होना पड़ेगा ना?
हैं। ओ हाँ
क्योंकि
ठीक है,
जीरो तो
सॉरी,
ऑलरेडी एक सॉल्यूशन
होमोजीनियस
है।
है, ठीक है, सो सॉरी। हाँ
तो
ठीक
ए
है,
बी दोनों को ही जीरो होना पड़ेगा, है ना?
जी जी
तो ए
जी,
बी दोनों जीरो हुआ मतलब क्या है? लिनियरली
इंडिपेंडेंट।
इंडिपेंडेंट। तो डिटरमिनेंट नॉन जीरो हुआ तो लिनियरली इंडिपेंडेंट है। अभी डिटरमिनेंट जीरो हुआ तो क्या होगा?
तो उसका सॉल्यूशन नहीं है।
इनफाइनाइटली मेनी सॉल्यूशन है। सॉल्यूशन नहीं है तो नहीं हो
ओके
सकता, क्योंकि जीरो ऑलरेडी सॉल्यूशन है, कुछ भी हो
ओके
जाए।
ठीक है ठीक है, मैं उसके साथ रिलेट कर रही हूँ जब
हाँ,
मुझे।
होमोजेनियस में जीरो ऑलरेडी सॉल्यूशन है, कुछ भी हो जाए। होमोजेनियस में दो ही पॉसिबिलिटी है, आइदर यूनिक सॉल्यूशन मतलब सिर्फ जीरो, और इनफाइनाइटली मेनी सॉल्यूशन। अगर इनफाइनाइट मेनी सॉल्यूशन मिल जाए तो कोई नॉन जीरो सॉल्यूशन तो मिल ही जाएगा उसमें, है ना?
हाँ जी हाँ जी,
तो उसके
तो
लिए
वो
लिनियरली
लीनियर डिपेंडेंट
डिपेंडेंट।
हो गया। ओके
ठीक है,
सर,
ये
एक्चुअली
बताया
ना
था मैंने 2 सेशन
ये
में।
सब समझ में आ जाता है, फिर पता नहीं कैसे हम कुछ ना कुछ ड्रॉप कर देते हैं, भूल जाते हैं।
हाँ, थोड़ा
कोई
एब्स्ट्रैक्ट है,
एक
वो बात
चीज
सही है, लेकिन
कोई एक चीज ड्रॉप हो जाती है, फिर वहीं पे कंफ्यूज हो जाते हैं।
हाँ
थैंक यू सो मच सर।
ठीक है। और कोई डाउट है? मतलब नहीं तो एक्चुअली कल तो बैठेंगे ही फिर से।
यस, थैंक यू सर।
ठीक है, मतलब डरो मत, मतलब इजी है, उतना मुश्किल भी नहीं है मैथ्स 2।
सर समझ में आ जाता है, और अब मैं ग्रेडेड असाइनमेंट में पूरी तरह फंसी पड़ी, मुझे कुछ नहीं आ रहा उसमें, जबकि सब समझ में आ गया था, पता नहीं क्या मुश्किल हो
थोड़ा
रही है।
वो मतलब पहले प्रैक्टिस असाइनमेंट का सॉल्यूशन देख लो। थोड़ा प्रैक्टिस का सॉल्यूशन है ना पोर्टल पे?
हाँ जी
हाँ,
ठीक है
थोड़ा
सर।
वो देख लो पहले। ठीक है,
ठीक है सर, थैंक यू।
तो समझ में आ जाएगा थोड़ा। ठीक है, ठीक है, गुड नाइट।
गुड नाइट सर, थैंक यू सर।
कल मिलते हैं फिर।
यस सर।